Hello, everyone. Welcome to the session. My name is Harshal Pimpalkhute. I'm on the product team here at Snowflake. I will be covering Model Context Protocol, or MCP, and we'll go through a few best practices, some demos, and also certain architectures. Welcome again, and let's jump straight in. Model Context Protocol has gained quite an adoption over the last few months. It allows for a standards-based communication between agents and tools, and we have enterprises adopting it for their agentic applications. A couple of disclaimers before we start talking about it. Anything that does not have a tag is not offered even in preview. Otherwise, you'll see tags for public, preview, general availability, and so on. So enterprises use data in their applications, and generative AI has been transforming businesses. Enterprises are using generative AI to achieve outcomes and reinvent the applications, reimagine end user experiences. And for enterprises, agents present the next frontier of insights. So you can use agents to retrieve both structured and unstructured data and build insights on it. But as you retrieve this data, you need access to structured and unstructured, like I mentioned earlier. You need the context because you take this data, you augment it to the input that is fed to the LLM, and that's how you end up with AI-ready data that is surfaced to the LLM for a response. You need to access data from different sources to execute these sometimes complex workflows. And uh, in a typical enterprise, data lives across different sources and different locations. You have your structured data with Snowflake, but then your code lives in GitHub. Your docs, maybe they live on Google Drive, and you need a standards-based approach to access all of this data. That's where Model Context Protocol fits in. Model Context Protocol, or MCP, is a open source protocol that provides a standards-based interface between applications on one side and the services, whether these are data services or these are task-based services on the other side. All right. So typically you have the MCP client residing in the host, communicate over MCP with the MCP server on the right side. So that's the Model Context Protocol right there. Some terminology. You have the MCP host. This is perhaps a compute node that hosts the application. Your application can be a custom application or one of the available agentic apps like Claude.ai. And your data or the information or the tasks that you want to execute can be spread across different vendors, different providers of data and applications. Some more terminology here. The MCP host, the MCP client connecting over the protocol with the MCP server. You collect the context, and like we discussed earlier, you augment this context and feed it to the LLM. It's important to understand that all of this was doable today. It still is using APIs, but if you do it with through APIs, you're really looking at an N cross M complexity. So what I mean by that is you have N different uh, hosts or applications on the left side, and then you have um, M different providers of data or services on the right side, right? And you have to build a custom connector for each one of these across and leading to a complexity of N cross M. Now with MCP, you still need to connect across, but you have a reduced complexity of N plus M. And the reason is you have still a total of n hosts and m servers, but then you just can use a model context protocol to achieve an n plus m complexity here, right? So a magnitude of order lower complexity compared to what you would traditionally. So with Snowflake MCP Server, a few benefits that I want to call out before we jump into the details. It provides seamless interoperability between the client and the server. It's a standards-based interface. We have followed the specification to a T and made sure that we have everything aligned to the standards that are recommended. And because this lives in your secure perimeter, you can apply the same governance rules that you would to your to the rest of your data, and we'll see in a bit just how that's possible, right? So that's the uh, maybe the high level. We're going to jump into details just in a bit. Uh, so a couple of other points before we talk about how you implement this or how you configure it. The tools that we support with the Snowflake Managed MCP Server, we include Cortex Analyst, which is used for retrieving structured data. Cortex Search, tool used for retrieving unstructured data. Very soon we're going to have Cortex agents so that you can perform orchestration on the server side, and custom tools so that you can wrap your own user-defined functions or stored procedures. So, so those are the pieces that you can define as tools. These can be discovered through the Snowflake MCP server. These can be invoked through the MCP server. And on the left side, which you don't see on the slide, is the MCP host and the MCP client invoking these tools through the MCP server. Yeah. All right. So a quick look at each of these tools, uh, or two of the tools, I should say. First one is Cortex Analyst, and with Cortex Analyst, you convert text to SQL. It's a deceptively difficult problem to solve, and our team has worked very hard to achieve state-of-the-art accuracy here with Cortex Analyst, and we have achieved over 90% accuracy. Um, and much higher compared to some of the other vendors out there. Uh, this is perhaps a backbone for the text to SQL is the backbone as you retrieve data from Snowflake. The next piece I want to call out is the semantic views. Semantic views codify the relationship, the logical relationship between all of your tables. They provide details about the metadata, such as the column names and some of the join relationships between these tables. It's a schema level object that stores all of your model information in the database, and you get improved accuracy with these semantic views. So another critical piece as you set up your agentic architecture to retrieve information from Snowflake. And the last piece that I'll cover here is the unstructured insights that are possible through Cortex Search. Cortex Search uses a hybrid approach based on both semantic search and a text-based keyword search to retrieve unstructured information, and is critical as you try to do both structured and unstructured data. And again, we've invested effort to provide a much more robust, reliable, and more accurate service compared to some of the other vendors out there, including Elastic and AWS. Before we talk about configuration, just to summarize this real quick, Snowflake MCP server, the managed MCP server, provide you with a governed, scaled, proven access to your data. It's governed because it's in the same governance boundary, the same secure parameter as Snowflake, as rest of your data. It scales to your demand. As your demand increases, you can have numerous of these MCP servers. It's based on the proven authentication, the same authentication that you use, the OAuth authentication, to access data for the past many years. And like I mentioned earlier, it is compliant with the standards recommendation as listed in the MCP protocol. And you'll see just in a bit it's flexible because you can define your tools and have them in the existing locations and yet reference them in the managed Snowflake MCP server. All right. So with that, let's shift gears. Let's talk a little bit about the details. Um, uh, an MCP server in Snowflake lives as an object, and you would issue a create MCP server, give it a name, and you would specify the configuration in a specification, like you see here on the screen. And this specification, what I've done is I've provided two tools. One is a Cortex search tool, uh, and it's the policy search. I give it an identifier, and the identifier specifies where it is located. So you'll see it's located in database one, schema one. And then the second piece I provide is a second tool, which is the Cortex Analyst. And again, in the identifier, you see that it's located in database two, schema two. And there's other metadata like the title, description. These are used by the remote agent. Okay, so you create this MCP server and as an object, and that's maybe the first part. A couple of other steps that I wanted to highlight. So you can create numerous of these, uh, and you can issue show MCP servers in account to see a listing of all of these MCP servers. Okay. And the next piece that I wanted to highlight was the security integration, and like I mentioned earlier, it is based on the standards-based proven OAuth, uh, uh, as recommended by the MCP protocol. You create a security integration of the type OAuth and give it some information, including the client, which is custom, and the redirect URI. So that's a security integration, and then you would initialize the server. So the server that we created in step one, you initialize it here, and that's just by invoking method colon initialize, and this is happening on the client side now. And you would also provide for the MCP on the MCP server side, you would provide the authentication details so that the clients can easily connect with the MCP server. And that's pretty much it at this point. You've initialized the server, you've provided the authentication details, and you can now discover and invoke tools. So you discover through the tool/list, and you invoke through the tool/call uh, methods, right? Yeah, in the tool/call, you actually provide it with the parameters, and in this case, this is just a sample where you can provide the name of the tool and the arguments to the tool as messages. All right. So what we just walked you through was creating an MCP server and initializing it uh, and using it to discover and invoke tools. One quick call out on the tools. We talked about Cortex Search and Cortex Analyst. You can also have Cortex Knowledge extensions on the MCP server. And what you see on the screen is on the slide is a quick example of setting up a Cortex Knowledge extension and using it as part of your MCP server. Cortex Knowledge extension allows you to use data from publishers such as Washington Post, and you can use this as part of your agentic application. So we're going to switch gears again and look at a couple of demos. This is going to be uh, let me pause here for a second. We're going to build a Cortex search service. We're going to build a Cortex Analyst semantic view, and then we're going to include these tools in your MCP server. And then we'll also see, as part of the second demo, we'll also see how to connect with these from your remote client. And the remote client that we're going to use is Claude.ai. So let's jump into it. So you see I have Cortex search, and to create Cortex search, I insert into a table. I insert the support transcripts, and these can be complaints from end users. I create a Cortex search service based on these transcripts, and that's on the search side. On the analyst side, I have revenue time series to create a semantic view first. So the semantic view includes tables, dimensions, metrics. This is the metadata that I mentioned earlier that you need, and I issue the show Cortex search service, and you see I have two of these. One is the Airbnb service, and the other one is a transcript search service. We're going to use the transcript search service today, and then transcript search, like you see, like you see on the slide here or on the demo here, you can. You have the identifier. It's located in a certain location, and it is of the type Cortex search service query. And then on the semantic view side, again, I do the show semantic views. I get the information, and this is again I have an identifier and a name there. All of this is going to into the MCP server, right? So at this point, we have the MCP server, uh, and then we create the security integration, like I mentioned earlier. I'm calling it test MCP2. I issue the command to create a security integration, and issue the command to get the client ID and client secrets. So this part is important because you will use the client ID and client secrets on the client side. And talking about the client, we move over to the client. Here is Claude.ai, and we first connect the connector or add a connector, which is through manage connectors piece. And I look for the connector. It's a custom connector in this case. uh, and I pull up the client ID and client secrets along with the URL. A quick note about the URL. This is the URL that you can get in your account information, and you would scroll down in your account and get the account/server URL. So you just copy that, paste it here, and then augment it with the API v2 databases, and the rest of it is coming from where your MCP server is located. Remember, MCP server is a schema level object, so it has a database and a schema. So you add that here, right? All right. So at this point, you've provided the URL for the MCP server. Next, you would, yeah, you add the MCP server name as well, right? Next, you're going to get the client ID and client secrets. So we just issued the show auth client secrets call earlier, and I got the client ID. I'm going to paste it here, and then I get the client secret, and that's the other piece that I'm going to paste here, right? So once that is done, you have the you have the connector ready. Okay. So now in the next demo, what we'll see is we created the MCP server, we connected it, and we're going to see it in action. So here you go. So in this case, uh, I have I've connected it, and I have the MCP demo connector here from Snowflake, and I'm going to use that to issue queries in Cloud.ai and get responses, right? All right. So if you recall, we had configured a transcript search service, and it carries the complaints from end users about internet. Let's say this is a telecom use case, and I've asked, do I have any complaints about routers in my transcripts, right? And it connects to the Snowflake MCP server. You see this with the small logo there, and you see it's executing the query, and it does provide you with the response. So that's the that's what you how you configure it and integrate it into your um, applications. These could be custom applications or one of the providers, one of the agentic applications that are out there, including Cloud.ai. All right, so we covered the setup, we covered a couple of demos. I want to talk about best practices and evaluations. Uh, these are ongoing efforts always, and as you continuously refine and improve your agent, you need the tooling on the MCP side, on the MCP server side, to achieve the same. So one quick call out on the authentication. We saw this in the configuration and the demo, but the client sends the client ID and secret that you've configured. Snowflake returns the token, and client uses this token to call tools, and the tool call provides the results. Right. Uh, Granular RBAC is enforced on the Snowflake side. Um, for invoking tools and for retrieving data. So, like I mentioned earlier, well, authentication is critical with any agentic application, and we have used the proven OAuth-based authentication with the Snowflake managed MCP server. All right, so you're going to get uh, run into a few issues depending on your use cases, or tool selection, uh, and tool calling. Sometimes with tool calling, you end up using the wrong query, or end up sending the wrong parameters for the tool. We've seen these as common mistakes. Uh, Again, configuration mistakes. In case of tool selection, you'll have to refine the prompt on the agent, on the remote agent, to ensure that it selects the correct tool, right? So that's one. And then you should invest cycles to improve the description of the tool. This is what the LLM is going to use to identify the tool and invoke the tool. You should be explicit about the tool parameters. Always list down what is each of the parameter and a description along with it, and provide instructions. Now, this can be possible in the prompt. I have seen orchestration instructions as well, where you instruct when to use the tool and when not to use the tool, right? So some best practices when it comes to tool descriptions. And finally, you should use evaluations to continuously improve the agent and the overall accuracy. With Snowflake, you have access to the tool evaluations. Uh, for each of the query, the input that you see here on the left side, you can see what the underlying thinking was, and then what was the final response, and you can perform an A/B testing across these, right? So with that, I'll say a couple of things that we have seen, or I'll share a couple of things that we have seen with the use of MCP. As customers, enterprises continue to evolve their application architectures, MCP is playing a role in this application architecture evolution. So you typically have a query agent that needs to connect to data, and with Snowflake, you can use MCP to connect with both your structured and unstructured data with Cortex Search, with Cortex Analyst, and Cortex agents as well. And as this space evolves, uh, we expect MCP is going to evolve. Maybe there are more functionalities that get added, and at Snowflake, we remain committed to adding these functionalities as both the MCP and the overall architecture evolves. Just to summarize, MCP Server on Snowflake provides you with an easy way and a governed way to access tools. By design, we have taken an approach with using a schema-based object. So the MCP server lives next to your data, and you can enforce the same policies, the same governance policies as the rest of your data. Uh, you Because we have followed a followed the MCP protocol, we're in complete compliance, and you can integrate with all compatible agents, and it's an extensible framework. because you can access all your data, you can add more MCP servers, you can add more tools, regardless of where the tools are located. That's what we have today, and you'll see there's plenty of quick start guides, uh, tutorials, documentation for you to review. We welcome you to try it out and let us know if you have any questions. Thank you.